Hello everyone, it's a pleasure meeting you in my mathematics class. Today, let me discuss a problem which deals with a distribution. Let me not disclose what the distribution is. I'll read the problem and then tell you what distribution has to be applied. See, the average rate of job submission in a busy computer center is 4 per minute. If it can be assumed that the submission per minute interval is Poisson distributed, calculate the probability that, question number 1, at least 15 seconds will elapse between two jobs. Question number 2, less than 1 minute will elapse between two jobs. Third question, if no jobs have arrived in the last 30 seconds, what is the probability that the job will arrive in the next 15 seconds? This is the problem. See, there is a computer center and the jobs come. The arrival of jobs to the computer is found to be at the rate of 4 per minute. That means the arrival of jobs. See, arrival of jobs to a computer is equal to lambda is equal to 4 per minute. 4 per minute. And it is assumed that the arrival of the jobs follow Poisson distribution. Hence, the inter-arrival of jobs will follow exponential distribution. See, arrival of jobs follow Poisson distribution. Therefore, the inter-arrival time of jobs follow exponential distribution. See, the arrival of jobs follows Poisson distribution. Therefore, the inter-arrival time of jobs will follow Poisson distribution with parameter lambda is equal to 4 per minute. So, these are the most required things that are to be. These are the most required things with which we can answer all the questions that are asked in the problem. Okay, so this is what we have. So arrival of jobs to the computer is 4 per minute, which is and it follows Poisson distribution, and hence the inter-arrival time of the jobs follow exponential distribution with the parameter lambda is equal to 4 per minute. This is what we have now. With this, we can work out all the questions here. Now, let me answer one by one. See, let t be the random variable of time between two jobs. So I am considering this t as a random variable, that it's a random variable which is the time between two jobs that are coming to the computer for doing. So now what is the first, this is the random variable. Now let us start answering one by one. At least 15 seconds will elapse between 2 jobs. That means, see, P of P of T, the time interval between these two, time between 2 jobs, I am taking that as a random variable, which is greater than or equal to, it is given to be 15 seconds. So I will convert this into minutes, as it is given that lambda is equal to this one. Since lambda is equal to what? I will write it here. Lambda is equal to 4 per minute. Either you must take this, convert this into minutes, or convert that into seconds. So I am converting this 15 seconds into minutes. Therefore 15 by 60. So this is nothing but what? This is nothing but your 15 by 60 to infinity. Because this is a job, and the next job we do not know when the next job will come. So it goes up to infinity. And this is your lambda into e to the power of minus lambda of x into dx. And here where lambda is equal to 4 per minute. So t greater than or equal to 60, 15 by 60 is equal to so much. This is nothing but what? So this is equal to, it is 1 by 4 of to infinity, this lambda into e to the power of, I will write it as here, I will take this lambda outside, e to the power of minus lambda of x into dx, that is lambda into e to the power of minus lambda x divided by minus lambda, and it goes from 1 by 4 to infinity. Okay. Now this is equal to, see, this lambda and lambda will go off, giving you minus of e to the power of minus lambda is 4, and this is minutes is how much? This is 1 by 4, and this is minus of, it is of x, it is 4 of x, and this is 1 by 4 to infinity. If you apply the limits, e to the power of infinity is 0 minus e to the power of, it is minus 1, e to the power of minus 1, because this will be 1 by 4, this is 4, you will get minus 1. So this is e to the power of minus 1, and therefore the e to the power of minus 1, I will just give you the value of this, e to the power of minus 1. So e to the power of minus 1 is 0.3679. So what is the probability that at least it will take 15 seconds between two arrival of jobs to the computer is 0.3679. That is the first question. That is, see, at least probability of at least 15 seconds between two jobs is equal to 0.3679. So this is our first question. So I have answered the first question. Let me pause on to the second question. See, this is my A. This is my A. Let me pause on to the next question B. See, once that lambda is known, and if we can understand what is the arrival and the inter-arrival distributions, it is easy to do the problem. Now next we will do the next question, namely B. See, this we have answered, and the answer for this is, it is 0.36. Next is, less than 1 minute will elapse between two jobs. That means, see, less than 1 minute. T must be less than or equal to 1 minute. t must be less than or equal to 1 minute. That means we want this. What is the probability of this? That is two jobs, and between two jobs the time lapse must be less than 1 minute. Here you are given, it is given to be 1 minute, and there is nothing to worry on this. So this will be equal to what? It is 0 to 1, because at the maximum between two arrivals it can be only 1 minute. So 0 to 1, and here it is what? It is lambda into e to the power of minus lambda x into dx. That is equal to, it is nothing but lambda into e to the power of minus lambda x minus lambda, and this is 0 to 1. So this lambda and this lambda will go off, giving you what? It is minus of e to the power of minus, it is 1 into, see, it is for 4 into 1 minus e to the power of 0. That is equal to, if you take this 1 minus e to the power of minus 4, but e to the power of minus 4 is e to the power of minus 4 is 1 minus 0.0183. So this is equal to this is equal to 7.9817. 0.1. That means the probability that the time probability is equal to 0.9817. Probability of two jobs is less than, see, this is time between two jobs. The between two jobs must be 1 minute. Therefore, this is point. So, therefore, the time lapse between, the probability of time lapse between two jobs to be 1 minute, less than 1 minute, is, the chances are 0.9817. 0.9817. Now the third question is, see, the third question, what it says is, see, if no jobs arrive in the 30 minutes, that means what? T, it is given that no jobs have arrived in last 30 minutes. That means, see, greater than or equal to 30. In last greater than or equal to 30, no jobs have arrived. And it is, see, T, and what is the probability that the job will arrive in the next 15 seconds? For the first 30 seconds, the job has not arrived. Therefore, what is the probability that in the next 15 seconds, the job will arrive? That means, here, 30 plus 15 probability. See, for 30 seconds, the time between two jobs now is 30 seconds. Still, it has not arrived. Therefore, what is the condition? And the question is, what is the probability that in the next less than 15 seconds a job will arrive? That is, T greater than or equal to 30 plus 15 slash 3 seconds. But this is a memoryless property, and this is equal to T of, see, probability of T greater than or equal to 15, and therefore this is equal to, this is memoryless property, and therefore this is equal to 1 minus P of T less than 15. So this is equal to 1 minus 15 it is 15 seconds. So this is 15 by 60 minute. So this is equal to 1 minus, we have already worked out what is the value of this p less than 15, that is equal to 0.3679. So this is equal to 0.6321. Therefore, the probability that the job will be arriving in less than 15 seconds, but already 38 seconds have gone without any job arrival. So that is, the probability is 0.6321. The question is, the job has not arrived in 30 seconds. What is the probability that the job will arrive in less than 15 minutes? That is what I have written here. So here, the jobs between 2 is t greater than or equal to 30. It has not arrived. Still it has not arrived. What is the probability that it will arrive in the next 15 minutes? This is nothing but your memoryless property, which is equal to 1 p of t greater than or equal to 15. But that is nothing but 1 minus p t of less than 15. But this 15 seconds, therefore I am writing it as 15 by 16 minutes. But this has already been found. Refer problem 1. See problem A. I have worked out this. So that is equal to 0.3679. So therefore, the probability that a job will arrive in next 15 seconds, given that the probability no jobs have arrived in the last 30 seconds. It is nothing but your memoryless property, which is p of t greater than or equal to 50, whose value is 0.6321. So this is all about the 3 problems. I will do more difficult problems in the coming